Hi everyone, today we're going to be talking about slope, and when I say slope, I mean the slope between 2 points or the slope of a line on a graph. And really that just means how steep the line is. And there's a couple of different ways that we can find the slope, or a couple of different equations we can use. So we're going to start with the easiest equation, which I like to call the word equation, and the word equation is slope equals rise over run. Now, what that means is when we look at a graph, we're going to go from the leftmost point to the rightmost point, and we're looking at how far I have to go up or down from the leftmost point to get to the rightmost point, and then how far I have to move to the right to get to that point. And then those two numbers combined or in a fraction will create my slope. So the easiest way to understand this is to go through some examples. So let's start with the first example. And I'm going to draw the graph here. Let's see, so okay, so it's not the best drawing, but here we are. So we have this graph, and if we want to find the slope of this line, the first thing to do is start with the leftmost point and try to get to the right point. And so what I'm going to do is almost create kind of like a triangle between these 2 points. So like this. And what I'm going to do is figure out how much I had to go up and then how much I had to go over. So how much I had to go up, I went up 2 chunks, or 1, 2, right? So what that means is that my rise is 2. Now the next step is to figure out the run. So now I have to figure out how far I moved to the right to get to that second point. So I went over 1, 2, 3, 4, which means my run is equal to 4. So that means if I know my slope is rise over run, then my slope in this case is equal to 2 over 4, which can be simplified because I can divide both of those numbers by 2. So it can be simplified to 1 over 2. And this is my slope of the line. Sweet. Okay, let's go through another example. Okay. Now, this example is kind of like a special case. It's a straight horizontal line. When we have a straight horizontal line, we still want to think about this word equation, rise over run. But let's say that we have 2 points like right here and right here, right? So I first want to find the rise. Now, did I rise at all between these 2 points? No, because they're on the same horizontal level, which means my rise in this case is equal to 0. Now, the run, I know that I went over um, 4 chunks, and so I would say run is equal to 4. Now, if I figured out my slope from there, because I know slope is rise over run, my slope would be 0 over 4, which 0 over anything is just simplified to be 0. So that means my slope is 0. Now, this is a special case only because anytime you see a straight horizontal line like this, the slope is automatically 0. So before we move on to the other equation, I wanted to show you a couple of other things really fast. Kind of like the special horizontal line case, we can have a vertical line like this, straight vertical up and down. And when that happens, we call the slope undefined. The reason why we call it undefined is because in this case, instead of having no rise, we have no run. And so you could have something like where your slope would be some rise, and the rise doesn't matter what number it is. Let's say it's 5 over the run, which is 0. Well, I can't have the 0 on the bottom of a fraction. If I were to try and plug that into a calculator, my calculator would give me an error. So anytime I have 0 on the bottom of a fraction, it's considered undefined, which makes this straight vertical line undefined, no matter how many points are or how many chunks are in between the 2 points I was given or anything like that. If it's straight vertical, the slope is undefined. Now, the last thing that I wanted to go over in terms of graphs is we've been talking about how we want to go from the leftmost point to the rightmost point. And the reason we do that is because we read a graph like we read a book from left to right. So just one more quick example. If I had some graph and the line went down like this, because we read a graph from left to right, this would have what we consider a negative slope. And what that means is that because we would go from the left to the right, instead of rising or going up, like from the left point to the right point, we had to go down. So that just means that the rise is negative. And so when we find that rise, it would be a negative number, which would make our slope overall negative. Okay, so now let's go back and I'm going to show you the other equation. The other equation is the more algebraic equation, and that equation is m equals y2 minus y1 over x2 minus x1. Now, the m stands for slope. I have no idea why they chose m, but then we have x2, or I'm sorry, y2, y1, x2, x1, and those come from the points. So let's go through some examples. We've got, let's say we're trying to find the slope between 15 comma negative 8 and 11 comma 6. All right, so, and I'm going to just write the equation down here so we can see it a little bit better. Okay, so the first thing that I like to do is label my points. If you remember from last year or the year before in your math course, when you graph coordinate points, it's always, your coordinate point is always x comma y. So I'm going to just start by labeling both of these x, y, x, and y. And just because the 15 and negative 8 came first, I'm going to make that x1 and y1. And then x2 and y2 are the 11 and 6. So now to go from here to my equation, all I have to do is just plug everything in. So I'm going to have m equals, now my y2 is 6, minus my y1, which is negative 8. And I'm going to put the negative 8 in parentheses just so we can kind of differentiate between those two negative signs, over x2, which is 11, minus y, or x1, which is 15. All right. So now we're just going to simplify the top, simplify the bottom. So 6 minus negative 8 is really the same thing as 6 plus 8 because those two negatives cancel each other out, which gives me 14. And then we have 11 minus 15, which gives me negative 4. Okay, so now I can simplify that a little bit because both of those things are divisible by 2. When I divide both of them by 2, I get 7 over negative 2. This is my slope. Okay, let's go through one more example, which is number 4. Okay, number 4, let's find the slope between negative 9 comma 6 and negative 10 comma 15. All right, so once again, I'm going to label my points x, y, x, y, and it would be x1, y1, and x2, y2. Okay, so if I use my formula from up here, if you remember it's right here, we're going to start with y2, which would be 15, minus y1, which is 6, over x2, which is negative 10, minus x1, which is negative 9. All right, now we just simplify the top. 15 minus 6 gives me 9, and then simplify the bottom. Negative 10 minus negative 9, the two negatives would cancel each other out, which would give me plus 9, so negative 10 plus 9 gives me a negative 1. Now, negative 9 divided by negative 1 is a negative 9, which means my slope is negative 9. And there you have it, slope.